Alright, this is skill 30, finding the inverse of exponential and logarithmic functions. And if we look at this example, we see number 5 here is an exponential function. And we know that because if we look at the numerator here, we see an exponential function right here. It's 2 to the x power with our variable in the exponent. And on the right side, we've got a logarithmic function. Right? And we see that because most of the right side of this equation is a logarithm, log base 4 of the quantity x to the third plus 7. Now, in both of these examples, I'm going to start off in a very similar way. I'm going to start off by switching x and y. So for example 5, I'm going to have x equals 2 to the y power minus 9 all over negative 3. And notice that I was careful here to keep y as an exponent. One thing I've seen is students being a little sloppy in their work and bringing this y down so that it looks like it's just 2 times y, which is going to give them a very different answer than having 2 to the y power. Once I've switched x and y, I'm then going to try to isolate this 2 to the x. So I'm going to multiply both sides by negative 3. Which is going to give me negative 3x equals 2 to the y minus 9. I'll then add 9 to both sides. So I have negative 3x plus 9 equals 2 to the y power. And now I'm at my final step. I have 2 to the y power. Don't be tempted to try to divide both sides by 2 or maybe take the y root of both sides. What we want to do here is use a logarithm. And specifically, I'm going to use a logarithm whose base matches the base of this exponential equation on the right side. So I'm going to take the log base 2 of both sides. And the reason I'm going to do that is because on the right side, when I take the log base 2 of 2 to the y power, that right side is actually going to simplify to just give me y. If we think about that, if I have the log base 2 of the quantity 2 to the y power, remember that's actually asking the question 2 to what power is going to give me 2 to the y, right? 2 to whatever power is going to give me 2 to the y. And in that case, this term right here has to be y. And so that's why log base 2 of 2 to the y simplifies to give us y. And once we have y all alone, we know that we're done. We've got our answer. It's the log base 2 of negative 3x plus 9. That's going to be our answer for number 5. Looking at number 6, we're going to have a similar strategy starting off. I'm starting with a logarithm, so I'm going to switch x and y. So I've got x equals the log base 4 of y cubed plus 7 plus 10. And I'm going to start by trying to get the logarithm all alone on the right side. So I subtract 10 from both sides. So I've got x minus 10 equals the log base 4 of the quantity y cubed plus 7. Now, there's multiple strategies you could use here. One strategy you could use is you could say, because both of these are equal to each other, I could, and I'm going to write this up in the top right, I could actually set them as the exponents of this base. I could say 4 to the power of the whole left side, 4 to the x minus 10, is going to equal 4 to the power of the whole right side, which would be 4 to the log base 4 of y cubed plus 7. And the reason I would do that would be because 4 to the log base 4 of y to the third plus 7, when it simplifies, is just going to give me y cubed plus 7. That's one way we could go about doing this problem. 1 second here. That's one way I could go about doing this problem. And so I would get y cubed plus 7 on the right, and then on the left I would get 4 to the x plus 10. Another way, though, is to just think about the basic definition of a logarithm. If I think about how the log base 3 of 9 equals 2, because 3 squared equals the argument of this logarithm, it equals 9, I can do the same thing here. I can rearrange this as an exponential equation by saying 4 to the x minus 10 equals the argument, y cubed plus 7. And notice that this method is now giving me exactly the same thing I had using the other method. I'm then going to subtract 7 from both sides, so I have 4 to the x minus 10 minus 7 equals y cubed. And then I need to get y all alone, so I'm going to take the cube root of both sides. So my answer, that's a 3, my answer is going to be y equals the cube root of 4 to the x minus 10 minus 7. And another way you might see this written would be the quantity 4 to the x minus 10 minus 7 all to the 1/3 power. Let me fix that, to the 1/3 power. So this is skill 30, finding the inverse of logarithmic and exponential equations.